Today we are solving systems of inequalities. This is day 2. So if you haven't watched day 1, you might want to do that. The essential question is, how do I solve systems of inequalities by graphing? Your learning intention: I'm learning to solve systems of inequalities. So you've got 2 inequalities to graph. Pause the video and see if you can graph them on your own. Well, I hope you tried. If you're looking at the first one, we begin at 2. We move negative 1/3, which is down 1 and right 3. So I start at 2, go down 1 and right 1, 2, 3. Now, is it a solid or dashed line? It is a solid line. I'm now ready to connect my points. Now the question is, do I graph up here or down below? Well, y is less than. So what I'm going to do is to put 0, 0 in. Is 0 less than 2? Yes. So I know my shading is underneath my line, which is where you should expect it to be if it's a less than problem. If you're looking at this, anything in that green, any point in that green shaded area would be a solution to that inequality. What about the next one? Where do we begin on the next one? If you did not try the first one on your own, pause it and try it now. Well, we begin at negative 2. We move 3 over 4, which is up 3 and then right 4. Is it a solid or dashed line? It's not equal to, so it is dashed. Negative 2, go up 1, 2, 3, right 1, 2, 3, 4. Dashed line. Y is greater than. That means we expect the shading to be up above. I can once again use the point 0, 0. Is 0 greater than negative 2? The reason you use 0, 0 is because it eliminates your x term. And that is true. It is greater than negative 2. So I know that my shading is above. And any point in this shaded region will be a solution to that inequality. Okay, so if you're looking at a system though, what is your solution? What is the solution to a system of inequalities? Well, the solution to a system of inequalities is the region that contains solutions to both of the inequalities. to both inequalities. This could also be considered the overlap of the shadings. So for the next ones, we're going to solve by graphing. We're going to list 2 points that are part of the solution set and 2 points that are not part of the solution set. So if you look, both of these equations are ready to graph. They're set up in the y-intercept form and they're ready to graph. So we'll graph them and see where the overlap is. For the first one, where do we begin? We begin at -3. How do we move? Up 4 and right 1. Is it a solid or dashed line? This one is dashed. Now, if it's greater than, I know it's going to be on this side. For the other one, where are we going to start? Well, we start at 3, +3. How do we move? Down 2 and right 1. Is this a solid or dashed line? This is solid. So if we're looking where y is less than or equal to, both of them we're looking at underneath the line. So if we're looking underneath the line here, this V shape should be the overlap. So let's see if the point 1, -2 is in the solution set. Okay, so I'm looking at the point 1, -2. Start with the first one. Is -2 greater than 4 times 1 minus 3? Is -2 greater than 4 minus 3? Is -2 greater than 1? No. So that is not the area we're going to use. We are looking where y is greater than, which means it should be on the top, not on the bottom. I was thinking less than. Both times y is greater than. So if you're looking at this not being part of the solution set, then 0, 0 would be for the first one. Is 0 greater than -3? Yes. But is it also a solution to the other one? Okay, so is 0 greater than 4 times 0 minus 3? Is 0 greater than -3? Yes, it works for the first one. Is 0 greater than or equal to -2 times 0 plus 3? Is 0 greater than or equal to 3? No. So it does not work for this second equation. So this area will not work. So now I'm thinking, this area is not good, this area is not good. What about here? What about the point 1, 4? Because it's got to be on the top side of both of those. So I'm going to plug 1 and 4 into the first one. Is 4 greater than 4 times 1 minus 3? Is 4 greater than 1? Yes. Is 4 greater than or equal to negative 2 times 1 plus 3? Is 4 greater than or equal to 1? Yes. So I know this area here is where my shading needs to happen. So what are two solutions to this? Well, we've already found 1, 4. Okay, we could do 0, 5. So we know a non-solution would be 0, 0. I could do 1, negative 2. Any point that is not in that shaded region would be a non-solution. There are a lot of points you can use. There's an infinite number of points you can use for the solution or for the non-solution. So let's graph the next one. Y is less than 3. So where is y less than 3? Well, that's going to be a horizontal line. It's going to be dashed because it is not equal to. And it will be at 3. It's going to be horizontal at 3. For the next one, we begin at 1 and we go down 1 and right 1. This will be a solid line because it is equal to. And in both of these cases, it's going to be less than. So if I'm looking at less than, I'm going to look at 0, 0. Is 0 less than 3? Yes. Is 0 less than 1? Yes. So I know that this area down below is the area I need to shade. It will stop at the line y is equal to is less than 3, and then it follows the other line down. Okay, we've already discovered one point, the point 0, 0. Any point in this shaded area will work. I'm going to use negative 1, negative 2. Why? Just because I picked it out. No big reason. For the non-solutions, I need something that's not shaded. So this would be 4, 0. This would be 0, 5. There's nothing special about those points other than the fact they are not in the shaded region. Okay, for the next two, we have to put them into the y-intercept form. So, x plus y is greater than 2. I'm going to subtract x from both sides. Y is greater than negative x plus 2. I start at 2. I have a negative 1 for a slope. Down 1, right 1. This will be a dashed line because it is not equal to. Now, the same thing for the other inequality. It's got to be solved for y. 2x minus y is greater than 1. Subtract 2x from both sides. The opposite of y is greater than negative 2x plus 1. Divide all the way across, or multiply by negative 1. Either divide by negative 1 or multiply by negative 1. If I multiply by negative 1, I have y. Then I have to remember this has to switch around. It's less than 2x minus 1. I start at negative 1. I go up 2 and right 1. This is also a dashed line. So the question is, where is it greater? And this is your first one. So it'll be greater here, but it's also got to be less than here. So greater means all of this, less than means here. So this is where, this corner here is where we think it should be. Let's use the point 2, 1. Is 1 greater than 0? Yes. Is 1 less than 1? That would be 2 times. Is 1 less than 3? Because that would be 2 times 2, which would be 4 minus 1. Yes. So we know that that is the correct shading. Okay, pause the video and see if you can do the next one on your own. Well, I do hope you tried. Step 1, set it up in y-intercept form. I'm going to subtract x from both sides. Y is greater than or equal to the opposite of x minus 3. This will be a solid line. I start at -3. And then my slope is -1. I go down 1, right 1. And I make the solid line. Okay, for the other equation, I'm going to subtract x from both sides again. And I've got 2y is less than or equal to the opposite of x plus 4. Divide by 2. Y is less than or equal to -1/2 x plus 2. This will once again be a solid line. Start at 2. My slope is -1/2, which means down 1 and right 2. This one's a little bit more difficult because we don't see the intersection point. So if we're looking at this, we're looking at the point where it is less than, so it's underneath here, and it is greater than here. So the less than and greater than is this strip in the middle. Let's see if the point 0, 0 works. Is 0 greater than or equal to -3? Yes. Is 0 less than 4? Yes. So that means the area in between is going to be our solution set. Remember, to check a point, all I do is substitute it in for x and y and solve. So now, we're going to look at solutions to these two systems. If I'm looking at a solution, I'm going to go over 1, 2, and go up 1. So the point 2, 1 will work. I can go over 4 and go down 1. The point 4, -1 works. What about some points that do not work? How about 0, 0? How about 1, -1? There's nothing exciting about those points other than these are in the shaded region, these are not. Once again, solutions. This time, I'm going to use 0, 0 because it's in the shaded region, and 0, -1. Non-solutions. Well, -1, 2, 3, -3, -4. -4, -4. Those are not in the solution set. They are not in the shaded region. So now we've got one more systems of equations, and we're going to do these by elimination. So this is a review. Pause the video and see if you can do that on your own. You have to scale one of the two equations to create your opposite. Which one is it? So I do hope you tried to do that system on your own. If you're looking at it, I can see that I can multiply the bottom equation by -4, and then I'd have a -4 and a +4 here. Or I can multiply by 3. I'll have a -15y and a +15y here. So I think that what I'm going to do is to multiply by 3. That first equation does not change. -4x minus 15y is equal to -17. The second one, 3 times -1 is -3x. 3 times +5 is plus 15y is equal to 3 times -33 is -39. I have created my opposites. -4x plus -3x is -7x is equal to -17 plus 30 plus -39 and you end up with -56. Last step is to divide both sides by -7. And x is equal to 8. Okay, I know what x is, but what is y? Which one of the 1, 2, or 3 equations am I going to use? I think I'll use the second one. So I'm going to substitute 8 in for x. So the opposite of 8 plus 5y is equal to -13. Add 8 to both sides. y is equal to -5. Divide by 5 on both sides. And y is equal to -1. So what is your solution? What is the point of intersection? 8, -1. So, how do you know when you're successful? You know you're successful when you can solve systems of inequalities. So we solved systems of inequalities. And then we also identified solution points. So hopefully after today, you've got a little bit better idea on the systems of inequalities and how to do them, and you will be able to get the practice done.